Welcome to today's lesson. Our learning objective is to identify significant figures and to apply scientific notation. Our language objective is to explain what makes a number significant. So let's take a look at today's lesson. Let's take a look at today's do now. So I am going to make you guys pause the video, do both questions, and I will show you the answers. So for number 1, rounded to decimal places, you get 5.64. For number 2, rounded to the nearest hundred, you get 100. Let's look at today's thinking. We are going to be talking about what are significant figures. So significant figures. We have significant figures tell us how precise a number is. How to determine significant figures. 1. All non-zero digits are significant. Number 2, all zeros between non-zeros are significant. Number 3, leading zeros in a decimal are not significant. Number 4, trailing zeros are not significant unless followed by or to the right of a decimal point, and sometimes this is ambiguous. So let's try this. Let's look at example number 1. For example 1, we are going to be identifying significant figures. It says for each of the following, identify how many significant figures the number shows. So let's look at number 1. We have 32.420. Here we have 5 significant figures, SF for short. Every single number here are considered significant. For number 2, we have the number 0.003, one significant figure. These zeros are not significant. We have one significant figure. These zeros are not significant. Again, this is a special case. Sometimes it's ambiguous because those zeros might actually be significant. Number 4, I am going to look at that last 3, and all those numbers in between are significant. The zeros in front are not significant. So here we have a total of 8 significant figures. Let's look at example 2. For example 2, we are going to identify significant figures. We're writing the significant figure for the following number. So our number has been given and we're working with that number. For number 1, it says we want to identify one significant figure. So in that case, we would have 100. For number 2, we want to identify 2 significant figures. So our number would be 130. For number 3, we are looking to write 4 significant figures. So we will get 125.5. For number 4, 5 significant figures. 125.46. So nice and easy. Let's turn the page. Now that we have done significant figures, let's take it to scientific form. So our next thinking, how do we write numbers in scientific form? Any number can be written in this form. We write it as a times 10 to the k power, where a is between 1 and 10, can include 1, but does not include 10. So how do we do this? We simply move the decimal point after the first non-zero digit. If we move the decimal point to the left, the value of k is positive. If we move the decimal point to the right, the value of k would be negative. So let's try these. Example number 3, writing numbers in scientific form. Give the scientific form for each. So for number 1, we have been given x is equal to 100,000. So I am going to take my decimal point, which is in back, and I'm going to move it 5 places to the left, making that number 1 times 10 to the 5th power. For number 2, we have y is equal to that very small number. So in this case, I'm going to start off the same way. I'm moving that decimal place. Again, 5 places, changing that small value to number 1 times 10 to the negative 5th power. Your goal is to get that a be a number between 1 and 10. Again, including 1, but not including 10. For number 3, we have z is equal to 4,057.52. We are going to move the decimal point 3 places. So we have our new number of 4.05752 times 10 to the 3rd power, because we only moved it 3 times. And last one here, w is equal to that very small number, moving the decimal place 4 spaces, changing my number, my a value. A is a number between 1 and 10. Let's look at example 4. For example 4, we are going to be writing numbers in standard form. So give the standard form for each. Here they gave us x is equal to some number in scientific form. So I am going to be moving the decimal 7 places to the right. For number 2, I am going to take that y and move the decimal place to the left, making that number really, really small. So whenever you see a positive exponent, the number is going to get larger. When you see a negative exponent, that number is small. You're going to include zeros in front. All right, let's look at example number 5. Here we are going to be doing operations using scientific form. We have been given x to be 3 times x 10 to the 7th power and y to be 4 times 10 to the 5th power. Number 1 wants us to add x and y. So I'm going to set it up. So there's my setup. Now, the one thing that we want to think about is we're adding 2 things that have a base 10 raised to a certain power. What we want is for these bases and exponents to be exactly the same. So I am going to focus on this piece here, the 5. I want this exponent to go up 2. That way, both of these terms would have a 10 to the 7th power. Now, I can only do that if I move my decimal place 2 places to the left. So I have my new setup here. So there's my setup now. Now that I have both of these 10 to the 7th power, I can actually go ahead and add my coefficients. And I'm going to leave 10 to the 7th power as is. Since this is already written in scientific notation, I am going to stop there. For number 2, they want me to multiply. So I'm going to set myself up. Now, when we multiply, we can multiply our coefficients. And we are going to be adding our exponents. So 10 to the 12th power. Since this is not written in scientific notation, I am going to go ahead and write it in that form. So my decimal place is behind the 12. I want it to be in between, which means that this exponent is going to increase. And that is all. So keep learning, keep growing, and I will see you in our next video.